There's an engineering principle that doesn't get taught in driver's ed. Cold attacks metal. Heat attacks chemistry. The thing is, once you actually count the failure points in a modern car, about 90% of them are chemistry. Rubber, plastic, fluids, lubricants, seals, coatings. So what damages your car faster? 30 below 0 Fahrenheit in January, or 35 Celsius above 0 in July? The math is not what most owners think. You'll get the answer at the end of this video, after 13 specific protection moves you can do this weekend without a single special tool. Today I'm walking you through 13 things that go wrong on your car between June and September, ranked from least to most important, with the actual chemistry of why each one happens. The one at number 1, the single most damaging summer move, is something most owners get wrong by accident every 5 years. Here's the engineering frame to hold in your head before we start. Cold makes things smaller and stiffer. Steel contracts. Plastic gets brittle. Rubber loses elasticity. Cold engines start hard because oil viscosity climbs, and your battery loses cold cranking amps. Most of that is reversible by the time the engine warms up. Heat is different. Heat doesn't just stress materials. Heat catalyzes chemical reactions. Every 10 degrees Celsius above ambient roughly doubles the rate of oxidation, polymerization, and chain scission in most automotive polymers. That's the Arrhenius equation, applied to rubber and plastic and oil. It's the reason a tire that survives 10 Minnesota winters can fall apart in 3 Arizona summers. Geometry and chemistry compound in a way winter cold simply does not. So when summer takes more out of your car than winter, what does that actually mean? It means summer doesn't restore itself the way winter does. Winter damage tends to be acute. Battery fails, hose splits, alternator gives up. You notice. You replace, you move on. Summer damage is chronic. UV exposure, thermal cycling on plastics, refrigerant pressure spikes. These accumulate quietly. By the time you notice, 3 years of degradation have happened in 3 months. 13 items. Let me walk through them. Number 13 on the list, and the easiest one to handle, is your wiper blades. Rubber wiper blades, sun-baked through July and August, lose about half their pliability by September. The blade still looks fine. It just smears more than it wipes. You'll notice it on the first heavy rain in October. By then, the rubber edge has hardened from UV exposure, and you're driving through the first cool storm front with effectively half a wiper. Replacement cost is $20 to $40 a pair. Takes 5 minutes. Do it in August before the rain returns. That's the cheapest item on this list, and the one most owners ignore. Number 12. Windshield chips. A small rock chip in May that you've been meaning to get filled becomes a 6-inch crack in August. Why does that happen? Thermal stress. The glass on the sun side of your car reaches 140 degrees Fahrenheit. The shaded side stays at 110. 25 degrees of differential across a single piece of laminated glass is enough to propagate any existing flaw. A $25 resin fill in May saves you a $400 windshield in August. If you've ever cracked open a windshield warranty quote and read the diagonal from existing chip exclusion clause, you already know what the dealer is protecting against. I've seen owners pay full price for replacements because they sat on a fillable chip for 60 days too long. Number 11. UV degradation of plastics. The UVA spectrum penetrates your car's windows. UVA is what fades your dashboard, hardens your steering wheel rubber, and cracks the upholstery on the sun-facing side. The degradation curve is non-linear. The first season barely shows. The second season is visible. The third season is structural damage. Published UVA degradation curves for common automotive plastics: polypropylene, ABS, polycarbonate. Put the half-life on direct desert sun at about 4 to 6 years. So a 12-year-old Phoenix car has been through 2 half-lives. Use a windshield reflector. Park nose out so your dashboard isn't the sun-facing surface. Sunscreen for plastics costs nothing. The replacement dashboard for a 2015 Civic runs $1,100 and 4 hours of labor. Number 10. And this is the move where one habit beats every product on the market. Parking strategy. Park west-facing in the morning so the afternoon sun hits the rear. Park east-facing in the afternoon. Park under any tree that doesn't drop sap. Park in a covered garage even at $5 extra for a working lunch. In Phoenix, San Antonio, Las Vegas, Houston, the surface temperature on a black-painted hood at 4 p.m. in July routinely exceeds 165 degrees Fahrenheit. I've walked through office park lots at 4 p.m. in July with a non-contact infrared thermometer in hand. The numbers tell the whole story. Shade is free. Shade is also the highest leverage protection on this list outside of the top 3 items. Number 9. Fuel system evaporation. Your fuel tank is sealed, but the EVAP system has a breather that vents through a charcoal canister. In summer, vapor pressure inside your tank rises sharply. Read vapor pressure for summer spec gasoline runs around 7 to 9 pounds per square inch. A healthy EVAP system captures the hydrocarbons in the canister and releases them through purge cycles. A cracked hose or a saturated canister throws a P0455 large leak code or a P0442 small leak code. You also waste roughly 1% of your fuel to evaporation. Fix is usually a $60 charcoal canister and 2 hours of labor. Sometimes just a hose clamp. Number 8. Engine bay heat shielding. The OEM hood liner under your hood is there for a reason. It reflects engine heat back into the bay during operation, and it also slows heat soak when you park. Most owners pull the hood liner off when it sags and forget to replace it. Replacement liners are $40 to $80. While you have the hood open, check the heat shielding around the exhaust manifold and the catalytic converter. Those shields keep your underhood plastics, wire looms, vacuum lines, plastic intake from baking in the secondary heat. The shields cost you nothing if intact. If a shield is rusted out, replace it. The wire harness it's protecting is worth $2,000 to repair if it cooks through. Number 7. Serpentine belt. Modern serpentine belts are EPDM rubber, ethylene propylene diene monomer, chosen for high heat tolerance. EPDM survives 120 degrees Celsius in normal operation. But the belt tensioner that holds the belt under load has a spring with a defined working temperature. At sustained high underhood temperatures, the tensioner spring softens by about 15% of its rated force. The belt walks, tracking goes off. You hear it as a chirp on cold start, a squeal under AC load. Pull up the service bulletin on your specific car. Most manufacturers spec a tensioner replacement at 100,000 miles or 7 years, whichever comes first. In my experience, the tensioner is what goes first, not the belt itself. The tensioner is $50. The labor is an hour. Quick one before the next item. Drop your daily summer high in the comments. What temperature your area is hitting most afternoons in July? I'm collecting these because we're going to do a regional breakdown video on which climates impact which failures the most. If you're in Phoenix or Las Vegas, you're not running the same problem as Seattle or Buffalo. Houston and Dallas are their own category. Subscribe with the bell if you want to be tagged when the regional video drops. Otherwise, on to number 6, where most owners start losing money without realizing it. Number 6. Battery and electrolyte. Lead-acid batteries, flooded or AGM, vent at higher rates in summer heat. The internal temperature of a battery sitting near a hot exhaust manifold in stop-and-go traffic can reach 60 degrees Celsius. AGM batteries have a defined vent rate when overcharged, and that's a published manufacturer spec. Above the threshold, the vent opens, water evaporates from the electrolyte, and your battery loses capacity permanently. The combination of summer heat plus an alternator pushing 15 volts because of a worn regulator is the most common reason I see AGM batteries die at 3 years instead of 7. Check alternator output at idle with the AC on. It should be 14.2 to 14.7 volts. Above that, the alternator is your problem, not the battery. Number 5. AC refrigerant charge. The most common AC complaint in July is a system that worked fine in May. So what changed? Refrigerant doesn't get consumed in a healthy system. If your AC is weak in summer, you're either undercharged from a slow leak or your condenser is dirty. See number 2 below. 2 refrigerants to know. R134A is the old standard, phased out in new vehicle production by the EPA SNAP rule starting in 2017. R-1234YF is the current standard. R-1234YF operates at slightly higher pressures and is mildly flammable, so the service handling is different. If your car was built before 2017, it's almost certainly R134A. After 2021, almost certainly R1234YF. The recharge cost difference is real. R1234YF is 8 to 10 times the cost per pound of R134A. Take that to the shop, not the parts store kit. Number 4. Brake fluid. Brake fluid is hygroscopic. It absorbs water from atmospheric moisture through the rubber lines and the master cylinder cap. 3 years in service, brake fluid that started at 0% water sits at around 3% water. 3% sounds small. I can tell you it isn't. The DOT specification for the dry boiling point of DOT3 brake fluid is 205 degrees Celsius. The wet boiling point, at 3% water, drops to 140. DOT4, dry, is 230. Wet is 155. DOT 5.1 is the highest of the 3 common spec grades. In aggressive mountain braking, long descent, full load, your calipers can hit 160 Celsius at the fluid. With 3% water in there, that's where vapor lock starts. The pedal goes soft mid-corner. I'd say $60 to $100 every 3 years for the fluid flush is the cheapest brake safety expenditure you'll ever make. The alternative is a runaway in the canyons. Number 3. Tire pressure. The placard on your door jamb specifies cold pressure. Cold means before the car has been driven, ambient temperature. The placard is calibrated assuming roughly 20 degrees Celsius ambient, call it 70 Fahrenheit, For every 10 degrees Fahrenheit above 70, your tire pressure rises about 1 psi from heat alone. Drive on hot asphalt in July, your tire reaches 80 Celsius surface temperature. Pressure climbs another 3 to 4 pounds per square inch. So a tire you set to 35 cold in a Phoenix July is running 39 to 40 by lunch. Overinflated tires wear the center tread, run hotter, and have less contact patch in corners. The rule for hot regions. Set your cold pressure 2 pounds per square inch below the placard in summer, when ambient routinely runs above 85 Fahrenheit. Not 0, not the placard, 2 below. Number 2. AC condenser cleaning. This is the single highest leverage move you can make on summer AC performance. The condenser sits in front of the radiator. It dumps refrigerant heat to the incoming airflow. Over years, it accumulates dust, road grit, leaves, pollen, dead bugs, and dryer lint. A blocked condenser cannot dump heat. The high side pressure climbs. The compressor cycles harder. Your system cools poorly even when the refrigerant charge is correct. Clean it from the engine side with low-pressure water and a soft brush. Not a pressure washer. That bends the fins. 20 minutes of cleaning recovers most of the cooling capacity you've lost to age. Cost is nothing. Tools are a garden hose and a soft, thin brush from the parts store. I tell every owner I work with, do it once a year, in May or June, before the AC actually has to work hard. Number 1. The single most damaging summer move. And it's a move you might be making accidentally about every 5 years when topping off coolant. Coolant ratio. The standard mix is 50% ethylene glycol and 50% water. That ratio is not arbitrary. 50-50 gives you the optimum balance between heat transfer capacity and antifreeze protection. Water alone has the highest specific heat capacity of common automotive fluids. That's what lets it absorb engine heat. Ethylene glycol alone raises boiling point and lowers freeze point, but it has poor heat capacity on its own. The 50-50 mix splits the difference. Owners get this wrong 2 ways. 1. You top off with straight glycol because the bottle says high concentration, and you assume more glycol equals more protection. 60-40 glycol to water has worse heat transfer than 50-50. Your engine runs about 10 degrees Fahrenheit hotter at the cylinder head under summer load. Over a decade, that 10 degrees is the difference between a head gasket that lasts you 200,000 miles and one that lets go at 120. 2. You top off with straight water because the coolant bottle ran out. 60-40 water to glycol has better heat transfer but loses the corrosion inhibitor packages. The freeze point protection drops to about -8 Celsius, and the water alone accelerates aluminum corrosion in your heater core and radiator. Buy pre-mixed 50-50, always. The $5 premium over concentrated is the cheapest insurance on this entire list. 13 items. 13 things that go wrong on your car between June and September if you don't pay attention. The 13 are easy to remember by category. Top 3 are fluids, coolant ratio, tire pressure, brake fluid. Numbers 4 through 6 are systems, refrigerant, battery, belt. Numbers 7 through 10 are mechanical and environmental, heat shielding, EVAP, parking, UV. Numbers 11 through 13 are cosmetic or cumulative, windshield chips, wipers, dashboard plastics. Back to the question I opened with. What's worse, 30 below or 35 above? Here's the math. Winter damage tends to be replacement events. Battery, hose, starter. You see it, you fix it. The car comes back to baseline. Summer damage is integration over time. The data on this is actually pretty clear. Published, UVA degradation curves. Published, EPDM thermal aging rates. Published, refrigerant pressure curves. And the Arrhenius doubling rule applied across all of them. 3 months of 100-degree Fahrenheit days does roughly the same accumulated damage as 18 months of -20 Fahrenheit nights. About a 6-to-1 ratio of accumulated wear. So my honest answer to which is worse is summer, by a factor of roughly 6. Not because any single hot day kills your car, because the chemistry compounds and your dashboard never tells you. If you only do one thing from this video, 1, make it number 1. Coolant, pre-mixed 50-50 every time. Don't buy concentrated. Don't top off with straight water. Pre-mixed only. $12 instead of $7 every time you top off. That $5 premium per gallon is the difference between a head gasket that goes the life of your car and one that lets go on a July afternoon at the worst possible moment. By the 1st of July, finish these 3 additional moves. Clean the condenser, check your brake fluid age, set tire pressure 2 pounds per square inch below placard in any region routinely above 85 Fahrenheit. Those 4 items, coolant, condenser, brake fluid, tires, cost you under $50 combined and cover the top 4 positions on this list. The other 9 items are next weekend work. Wipers, hood liner, windshield chip, EVAP check, battery test, belt inspection, parking discipline, UV reflectors, and the heat shielding audit. Those wait without urgency. The top 4 don't. Pre-mixed 50-50 by July 1st. That's the whole video in one sentence.